Download this code from codegive.com, link in the description below. Certainly. The fast Fourier transform, FFT, is an efficient algorithm to compute the discrete Fourier transform, DFT, and its inverse. In Python, the numpy library provides functions to perform FFT and IFFT, inverse FFT, operations easily. Overview of FFT. One Fourier transform converts a time domain signal into its frequency components. 2 FFT, a faster algorithm to compute the same transform. 3 applications, signal processing, image analysis, solving differential equations, etc. Numpy FFT functions. The following are commonly used FFT functions in numpy. numpy.fft.fft computes the one-dimensional endpoint discrete Fourier transform, DFT. numpy.fft.ift computes the one-dimensional endpoint inverse discrete Fourier transform, IDFT. numpy.fft.fft2 computes the two-dimensional discrete Fourier transform. numpy.fft.ift2 computes the two-dimensional inverse discrete Fourier transform. numpy.fft.fftn computes the n-dimensional discrete Fourier transform. numpy.fft.iftun computes the n-dimensional inverse discrete Fourier transform. numpy.fft.ftshift shifts the zero frequency component to the center of the spectrum. Installation. If you haven't installed numpy, you can do so using pip. Example, one-dimensional FFT. Let's create a simple example to demonstrate how to use numpy's FFT functions. 1. Import libraries. 2. Create a sample signal. We'll create a simple sinusoidal signal. 3. Compute the FFT. 4. Plot the results. Explanation of the code. We import the required libraries, numpy for numerical operations and matplotlib for plotting. We define the sampling frequency, interval, and length of the signal. We create a time vector and generate a sinusoidal signal with added noise. We compute the FFT of the signal and obtain the frequency bins. Finally, we plot both the original signal and its FFT. Conclusion. This tutorial provides a basic introduction to using numpy's FFT functions to analyze signals. You can expand this knowledge to two-dimensional FFTs for image processing and other applications. Remember that the output of the FFT is complex numbers, representing both the amplitude and phase information of the frequency components. Feel free to experiment with different signals and parameters to see how FFT behaves.